Hello everyone and welcome back to the Kohi Game Engine series. Today we're going to tackle system fonts. So in the last video we actually got our bitmap fonts up and running, we got our font system up and running, and we've sort of talked about system fonts off and on as we've been talking about the concept of text and rendering and all that. And so system fonts are basically where we're going to load up font binary files. So the fonts that you can download from the internet and install on your OS, or maybe the fonts that are already with your OS. And we are actually going to load font and glyph information straight from that and generate atlases on the fly. And we're going to use all of this to be able to have a wide range of characters without having to generate these massive bitmap fonts, both the definition and the texture. And it'll also allow us to have different sizes of that font and be able to use those things a little bit more easily on the fly. And so, as I've kind of alluded to, we're going to have a sort of hybrid solution where we auto-generate a atlas, a texture atlas, and the glyph information based off of what we need at the time. And so our textures will be fully dynamic, and we will from there go ahead and add characters as we need them. We'll generate some basic characters, A through Z, lowercase, capital, things like that. We'll generate some sort of defaults that we're probably always going to need to use. But then we can, sort of add additional characters as we go. And then we'll go ahead and take a look at what those atlases look like once we've generated those things. So before we get started, though, there are a couple things that we need to put in place to prepare for this. So one of the things that we're going to wind up using, and this is one of the other few instances where I'm actually going to point to a library to do this, is we are actually going to be using Sean Barrett's STB TrueType library to load the font files. And this is because loading font files is a large and very, very complicated thing. And it's not something that I find a whole lot of value in actually parsing from scratch. So similar to images, there's just not a whole lot of value in doing that. Now, we could use the OS level ones as well, but I find that the STB TrueType gives us pretty much everything that we need, and it's a super lightweight header-only library, just like the STB image that we used earlier. So again, this is one of the few instances where we're actually going to do that. So I've gone here into the GitHub page for the STB library, and specifically we're going to pull STB TrueType. And so I've got that pulled up here. I'm going to go to raw and select all of it, and go in here to our project here, and I'm going to go all the way down here to our vendor folder. Let me just find it real quick. So right here, and I'm going to create a new file, and I'm going to call this STB TrueType. Oops, if I can spell correctly here. .h, and I'm just going to paste this in, and that is it. Okay, so you can see here that it's about 5,000 lines of code, and a lot of that actually includes documentation. So I've taken the time to sort of read through this and get an idea of how the library works, and I'll loosely explain it, but I'm not going to explain it in great detail because all of this is actually included here. So there are some warnings in here about security and not using this on untrusted font files because of arbitrary memory and things like that. So I would say definitely take the time to read through this file, understand it, and how it works, right? There's a lot here. There's a lot of work that's been put in over the years to make this work. And so it's something that is definitely going to save us a little bit of time on something that we really don't need to dive it too deep into just to get things working. All right, so the next thing that I want to do is I want to take a quick look at texture system, because I think there is one thing in here that I forgot to actually do, so actually let me texture system H. Let's see, so we have the resize. Okay, yeah, that's what I thought. Okay, so one thing that I forgot to do is we have this texture system write data method that we sort of stubbed out a header for. We're not calling it yet, but we're about to use it. So we're actually going to need to implement that because for some reason I missed it. So it should be here after texture system resize. So we'll go here, and right after that we'll implement this function. And basically all this is going to do is just a pass through to the renderer to say if we have a texture, go ahead and call render texture write data, pass along the texture, the offset, size, and the data, and then return true. And then otherwise go ahead and return false. So I'm not sure why or how I missed that, but there it is. Okay. So we have a lot of ground to cover. So in this particular video, I'm probably going to go pretty quickly with all of this because, you know, there's just, like I said, there's just a lot to cover. So I think probably the next place I want to start is probably in resource types. So resource types. I just want to go ahead and add the proper resource type here. So we have already we have the resource type bitmap font, and we just need to add one for system fonts so that we have that. And then of course we have all of our face information for our bitmap fonts. Let me just find them here. So here's all of our font data here. I'm going to put this after bitmap font resource data, right? So we have all of our bitmap font types here. We need two more structures. We need one for an individual system font face, and then we need one for system font resource data. So this is going to work pretty similarly to the way that we implemented bitmap fonts. The one big difference is we're going to have variants, what we're going to call variants of the system font. So we'll have a system font like, you know, Arial or something like that, but then we're going to have variants of that based off of font size, and that is going to allow us to have different atlases for different font sizes. That's the way I'm choosing to do it for now. We may eventually want to try and combine those things into all into the same map, but I don't find the complexity that comes with that all that much worth it. I think it's going to be much easier to maintain if we just keep those things separate. So that's the way I'm going to do that for now, and I'll explain that a little bit further once we get into that. The next thing that we're going to need is actually the loader. So I'm going to go here to resources loaders, and I'm going to add a new file. We're going to call this SystemFont loader. Not loafer, loader. So we'll do the H file first. And of course, this looks pretty similar to what we have before. I'll go ahead and change this date to, what is today? Let's see. There we go. So go ahead and update that. This is, of course, just a copy pasta from other files, so I keep forgetting to update the dates on those. But all we have here is basically our loader create function. And so that obviously means that we need to go ahead and create the C file for that. So SystemFont loader.c. And in this guy, we're basically going to do something very similar, at least in concept, to what we did in the bitmap font loader. So we're basically going to include all the files we need, our logger, our k-memory, k-string, things like that, our file system, of course. We're going to also have the font file type here. So we're going to have our not found, our KSF, which is for Kohi system font, and then what we're going to call a font config. And before I jump too far into this loader, we're actually going to take a look at one of those font config files look like. But we'll also have the supported SystemFont file type. So this is basically the equivalent of what we did in the loader for bitmap fonts. So it's very, very similar to that. So in fact, I think actually before I continue with this, I should probably go ahead and create the assets for the font configs. So let's go ahead and do that. So I know we're jumping around here a little bit, but as you can see here, I've added 2 font files. So there's one here that is a TTC. That is a true type collection. So that's actually, that includes multiple fonts. And then I have this Ubuntu Mono R, which is for regular, .ttf. So that is a single font. So basically a TTC can contain multiple fonts or a collection of fonts, and a TTF contains a single font. So we're going to support both. And actually, if I go here to, let's see, we want to, where is the option that I'm looking for? Open containing folder. So if I drag this to a new window, we have our TTC here. So if I open that up, we can actually choose which face we're showing. So you can see here that this has got 10 different files, fonts in it. So if as I'm changing this, you can see here that we're changing the various face. Okay. If I open up the Ubuntu Mono R, we see here that we just have one. Okay. So I just wanted to kind of touch on that real quick. And so, like I said, we're going to wind up actually supporting both. So with that, we need to create what is called a font config. And this is basically going to be a way to tell us what the name of the font is, or specifically the file of it, and then what all the faces are in that file. So in the TTC, it can be multiple faces. So I'm going to go ahead and create a new file under our assets fonts, and I'm going to call this noto sans cjk.font config, font CFG. Okay. And in this, I am going to paste the following. So this looks a lot like our other configuration files where we have comments. In this case, we have a file that is to be loaded. So that's the binary font file. And then what I've done here is I've included all of the faces that we actually want to load in the order that they show up in the font. And so you can actually open up the font to figure out what those things are and what those faces should be. The reason I have done this is trying to parse the font face names out of these files is somewhat unpredictable and doesn't always work right, and sometimes doesn't work at all. And so it's much better to sort of declare it this way, and then we can use array indices to pull it out. They're always going to be in the same order, but trying to obtain the font name is a little bit weird sometimes and highly inconsistent. So this is the way I've elected to do this, is just a simple font config file. So we have one here for the Noto Sans font, the CJK variant, which is the Chinese, Japanese, Korean. And then I'm going to create another new file here, which I'm going to call Ubuntu mono.font CFG, or font config. And this one is going to be a lot simpler because it just contains a single file, the TTF file, which contains a single font face. So we'll need these. These are sort of metadata for now. We'll need these at least in the short term. I might eventually enhance this to not require this file, but at least for the sake of getting going quickly, I've elected to do it this way. So those are our font configuration files. So there's nothing too crazy there. So now that we understand what the layout is of that, it's a pretty simple configuration file. We can now go back to our SystemFont loader and start implementing that. So similar to the bitmap font file, we are going to have a import process for font config files. So that's our sort of non-binary version of the file. And so what we'll do is we'll be able to read that in and process the data, and then we'll generate a KSF file. And then that's basically the binary compiled font file. And then from there, if one of those KSF files exists, we will read that as opposed to the font config file. Now, I will point out, I am going to put the logic for this in place to actually have all this hooked up, but I did run into some issues off screen that I've not yet figured out in terms of actually successfully writing out this KSF file. So it's actually giving me some trouble. So while I figure that offline, I'm going to get SystemFonts working from just the font config for right now, and we'll handle the KSF file bit of it in a future video. So anyways, we have that same process for loading up. So what I'm actually going to do here is I am going to basically paste in the entire load method because it is widely the same as what we've already seen with the bitmap font loader. Let me kill that terminal. So basically we just do some sanity checks up here, build ourselves a format string, get a file handle. We have our supported file type count, an explanation here of how these files are used, our supported file types. So we have our .kbf, that should be KSF actually. And our font config. And then we go ahead and we build out the path. We check first for the KSF. If that doesn't exist, then we fall back to the font config and try and load that. We make sure that we actually found something. We go ahead and start setting up the resource data. Depending on the type of file, we either import or we read the KSF file, or bleat about it if we don't have either one. Close the file. Check to make sure that we didn't have any sort of errors, set up the resource, and return true. So again, this is almost carbon copy of what we actually had in the bitmap font loader. There's just a few specific steps to the file format here. So with that, we now need to move on to the import process of the font config file. And again, this is actually pretty similar to files that we've handled in the past. So we're going to read line by line, check out the very beginning of the file to see what kind of line we're dealing with, and then go ahead and extract out the font name or the file name. Okay, so with that said, basically I'm going to again slam this whole thing in here because again it's mostly stuff that we've seen and it's not really the important part of all of this. So all this does is reads each line of the file. Same exact thing as we've done several times before. We trim it, get the length of the line, check for comment lines or empty lines, skip those. And then we go ahead and we split the string based off an equal value. If there is not an equal value in that string, or an equal symbol rather, then we say, hey, there's probably an issue with this file. We have a line that's not empty, that's not a comment, that doesn't have an equal sign. And in this particular file format, they all should. So we go ahead and skip that line if we actually find that. So here we actually parse out the name of the variable and then the actual value of the variable, which is basically on both sides of that split operation. So if you take a quick look here, the variable name would be here, the variable value would be here, okay? And so we basically say, well, are we dealing with version, which we don't have yet, but we will possibly in the future. Otherwise, if we're dealing with file, then we can go ahead and parse that out. And then at that point, we open and read the file as binary and save into an allocated buffer onto the resource itself. So we go ahead and we read the full file path there, which is the one that we would have parsed here. And that would be the file pointed to here. So this, in this case, the TTC file, or in this case, the TTF file. So we go ahead and read that as binary and save all those bytes onto the resource itself. And that is saved off here as font binary. So we go ahead and get the size of that and the binary itself. That way we can use it in the near future. Okay, so in the event that we actually have a mismatch between the binary size and the actual file size that was read in, we're gonna go ahead and warn about that. It should work anyways. I actually haven't seen this come up, but since we actually have those as two separate things, we should probably verify that they match. And then we go ahead and close the handle. If we have a face, then basically we create a new SystemFont face structure here. And then we go ahead and we keep the face name, a copy of that in there, and then push this to out resource fonts. Okay. And then, so we basically just loop through this until we actually get to the end of the file. And then we go ahead and we close the file. And at this point, we make sure that a binary file was loaded, and at least one font face was found. So if we were to have a font config that had no faces in it, this is where we would detect that, because we should always have at least one. And we also need to make sure that this font file actually existed and was loaded. So we check that here. If not, we bleat about it and return false. At this point, we take all that information that we found and we go ahead and we write it out to a KSF file. So with that said, I'm going to space this down a little bit and put our right KSF file here. Now this has a to-do on it because, like I said, I've actually tried working on this, getting this working off camera, and I'm actually running into some issues with it. So for right now, I'm going to leave this as a to-do, and we'll come back to it later. However, I do have the read portion of it done. And so that is basically going to be the same as we've dealt with for other binary formats. So we have some header information, the magic number stuff, etc., etc. We read the size of the font binary, the font itself, the number of faces within that font file, and then we go through and process each individual one, and then we go ahead and we return true, right? So that is the read. Like I said, the write isn't in place yet. We'll have to do that in the future. So basically this means that we're always going to be loading from that font config. So now that we have those, obviously we have our loading set up, but we also need our unloading. So that basically just destroys any D arrays that we have created, as well as any font binary information that we might have loaded. And then finally, we have our loader create method, which is what assigns our function pointers, our resource type, and so forth. So I realized that I did kind of skip over a lot of stuff at a very fast pace for this, but if you guys need more detail on that, feel free to pause the video or take a look at the latest commit. So with all that said, that is all there is for the actual loader itself. The only thing we need to do now is actually hook up the loader. So we'll actually need to go to the resource system.c file and go here to the top. And we have our bitmap font loader, so we're just right below that. We are going to go ahead and add our system font loader. And then, as you probably have surmised, we are going to come down here to where we register our loaders and register a new system font resource loader. Okay, so that, I believe, covers all the stuff that we've seen thus far. That's pretty much a duplicate of anything that we've had up to date. So the real sort of meat and potatoes of this is actually going to be in the font system. That's where most of these changes are going to take place in this video. So we'll open up the font system C and we'll go all the way to the top here. And we'll need to add some stuff. So right after our includes, right here, we actually are going to need to add in a define for STB TrueType implementation before we actually include the file. And this is because the STB TrueType by default does not actually have the header declaring all of the actual function definitions, right? We only have all these declarations, but we don't actually have the definitions of them. So if we use this, that is where we actually get all these definitions for those functions. And we can get those right out of the header file, which is exactly what we want to do. So we'll go ahead and define that. And then similar to how we had our bitmap font internal data, we are going to have something that is called SystemFont variant data. And so this is sort of at the same level as our bitmap font. Our bitmap font, remember, can only have one font size, whereas our system font can have many font sizes. So a system font variant is based on the individual sort of code points that we're using, as well as a scale factor, and then essentially a specific size for a given font. So we have that, and in combination with that, we have right here our bitmap font lookup. And with a bitmap font lookup, that means we obviously need a system font lookup. So this has a reference count and an ID just as before. And instead of having just a single font data here like bitmap does, this actually has multiple font datas, which is our size variants. So we have an array of those here, which is a D array. And that has basically one for each variant. So in our case, we'll be loading it at 20 pixels and 31 pixels in our example. So each one of those would be a font variant. We also have the binary size. That's the size of the binary font that we load in, the TTF or TTC. The face, the font binary itself, an offset, which is basically an offset into this font binary. And then we also have an index, which is the font face index. So if you recall, basically the TTCs can have multiple font faces. So a font lookup is basically held to one of those faces. So in our case, with the TTC that we have, we're actually going to wind up with 10 system font lookups, all with different faces. And then when we actually want to use that font, we'll use the individual face of the font that we want to use. And then finally down here, we have the STBTT, which is the STB TrueType. I can't talk today. STB TrueType font info. So this is the parsed information that STB TrueType actually uses. And we need a copy of that to generate glyphs and stuff. So that is right there. We'll also need to modify our system state here a little bit. So we have a bitmap font lookup. We also need a system font lookup. We have a bitmap font array. We also need a system font array. And then we also have a bitmap hash table block. We need a system hash table block. So that's a system font hash table block. We're also going to need some new sort of private methods. So we have our setup font data and cleanup font data, but we're also going to need create system font variant, rebuild system font variant atlas, and then verify system font variant. So based on the explanations that I gave in the last video, you could probably guess where these are going to tie in, but we'll go over all of that. So next, we obviously have to modify our memory requirement here. So what we're going to wind up with is we're going to have a bitmap array requirement here, and then right after that, we are going to have our system array requirement, which is full of system font lookups, right? And then from that, we're going to have our hash table, our bitmap hash table requirement. So that means we also need a system hash table requirement. And that, of course, means that our memory requirement calculation here is going to change as well to take those things into account. So our overall structure will be our struct requirement for the font system state itself, and then the bitmap font array, the system font array, the bitmap font hash table, and the system font hash table. All right. So with that, we now also need to declare our system fonts array just as we have for the bitmap fonts array, and that is going to be. Oh, I did not actually include the system font block. So right there. So basically, what this is going to do is we have a block of memory here for our system font array. And that's going to take the this address here for this bitmap array, and it's going to be right after that. So it's going to say take that block, and then after the array requirement for bitmap fonts, that's where our system array block starts. And then we're just going to assign those things here. And then since we have the bitmap hash table block, this has been shifted down further in the array. So that is actually now the system array block plus the system array requirement, so it comes after that. And then we have the system hash table block, which comes after that. So that is simply this bitmap hash table block here plus the bitmap hash table requirement. And then we'll have the second hash table being created. So we have one here for the bitmap fonts, and then we'll have one here for the system fonts. And then obviously that means that we're also going to have to do the same sort of fill operation on the system font lookup. And then just as we go ahead and we fill the array with invalid entries, we alluded to that here sort of with this comment because we knew this was going to be coming. We have the one for bitmaps and the one for system fonts. And of course, that's just also setting the U16 invalid ID as well as the reference count to 0. Now, those of you who might ask, well, why don't we just put this into a single loop? Technically speaking, the max could be different for these two things. And so we might have space for more bitmap fonts than we do system fonts or vice versa. So we don't want to assume that those arrays are the same size. Okay, so a little bit further down, we have load up any default fonts for bitmap fonts. We're going to do the same exact logic for system fonts. So it's basically just going through the same exact type of loop here. It's just loading our system fonts instead, and then bleating about it if any of them fail. Okay, so next we have our shutdown. So obviously, since we are cleaning up our bitmap fonts, that means that we also need to clean up our system fonts. So this is a little bit more involved because we have variants within those system fonts. And hopefully this will sort of help you understand how these variants are actually going to be structured. So basically what we're going to say is we're going to loop through all of the system fonts. For any of them that don't have an invalid ID, we are going to get the count of the variants on that, and then clean up the font data on each individual variant of that. And then we can go ahead and kill the ID. The only other thing is, does this... I don't think we're actually killing the D array there. Yeah, so I did miss something here. So we're getting the variant count. We probably need to also say D array destroy, and this is going to be state pointer system fonts sub I dot size variance. Right? We need to actually clean up that array. Because otherwise that's going to be a memory leak. I guess it's on shutdown, so it doesn't really matter, but there we are. Okay, so I believe that is everything we need to do there for shutdown. And the next thing that we need to do is we need to actually handle our font system load system font. So this is where we actually start loading up some of the resource data. So the first thing I'm going to do is actually just empty this out because we don't need that anymore. And obviously the very first thing that we're going to need to do is we are going to check whether or not we can take multiple fonts or not. And so we're going to load up the resource for the system font. And then if that fails for some reason, we're going to go ahead and bleat about it. Otherwise, we're going to continue. And then we are going to go ahead and keep a casted pointer to the resource data for convenience. So this is sort of similar to what we did for our bitmap fonts as well. Next, we're going to loop through the configured faces. So we're going to have a loop here to iterate those. So that's just the font face counts and resource data fonts. And for each font face, we are going to go ahead and process that. So we have just taking a pointer there to the individual face. And then the first thing that we're going to do is make sure a font with this name doesn't already exist. So we're going to validate that against our hash table to make sure that we're not loading the same font twice for some reason. And if we are, we're going to warn about it and then just continue as a success, because we don't want that to be a hard error, but we do want to notify the user of it. Obviously, the next thing that we'll need is an ID. So we'll need a free space within the array to store it, and then we'll have to verify that we got one of those. So we have that. And of course, we will have to go ahead and grab a lookup. So that just basically says we're going to have a new system font lookup, which is going to be the state pointer system fonts at the new ID. We'll go ahead and copy over the binary size, the font binary itself, the face, we're going to string duplicate that. And then the lookup index is going to be I. And then to hold size variants, we are going to create a new D array that's just empty for font data of size variants. Okay. Now, this part is actually where we sort of start using STB true type a little bit. So the first thing that we're going to do is we're going to get the binary offset for the font face index that we are looking at currently. So we have this index here, which is I, which is of course the font face that we're currently looking at. And so we're going to get the offset basically in bytes by calling sbtt get font offset for index. We pass the font binary, which remember is that entire font file. And then the index, which in this case is going to be I. Then we'll have a call to sbtt init font, which does a bunch of standing up of internal structures and whatnot for that font. And that uses the lookup offset that we've just passed here, plus the font binary, plus the address of the lookup info. So basically what that does is in the lookup, we have this info object, this sbtt font info. This gets populated by this call, okay? And then the result basically returns a essentially as a non-zero number if we have a success, okay? And so if we actually get a 0, that indicates a failure and we need to bleat out. Now, I know this because I've read the sort of documentation in the file, so I'm not going to step through that. If you guys are interested to know what those individual codes are, or what values can be returned, feel free to open that up and read through it. Okay. So the next thing that we're going to do is we are going to create a default size variant. And that is basically going to be our config default size that we passed in. So you heard me mention earlier that I was going to use a size of 20 and 31. Well, 20 is going to be our default size, and then we're going to manually load a size of 31 to go ahead and use. And so we are going to use our create system font variant using our lookup, obviously, our default size, which is going to be 20 pixels, the name of the face that we're going to use, and then the address of the variant to be populated. Okay, so we have a variant that's been declared here. We're going to populate that guy with the created system font variant. If that fails for some reason, we are going to write an error, but continue and try to keep processing the other fonts in the file. We also need to perform setup for that variant. So we've created it, but we also need to perform some setup on that that font data, and that has to do with all of the stuff that we kind of created before with the atlas, getting the atlas stood up and whatnot, and ready to go. And then we're going to add the variant to the lookups size variance. So we've just got a DArray push on that. It's nice and simple. And then we'll go ahead and set the entry ID here right before we update the hash table. So we'll set the ID on this, and then we'll go ahead and update the hash table with that newly created ID. Finally, we'll come down here and we'll just return true to let us know that everything was successful. Okay, so that is at least the first part of our system load system font, or font system load system font rather. This is a bit pen, pineapple, apple, pen, I suppose, but it is what it is. Okay, so that's sort of what the high level view of it is, right? That's how variants are sort of created and whatnot. Now, the next thing that I want to do is I want to go ahead and tie in the acquire, so the acquisition. So that's going to be after we load our bitmap font here. So our acquire, if you recall before, we check the type. So we have the text type is UI text type bitmap. So here's our bitmap acquisition. Here is our system acquisition. Right now it just throws an error and returns false, saying it's not supported. That's rubbish. So we're going to get rid of that. This is going to be doing a lot of the same work that is being done in the bitmap font acquisition. So this is going to look pretty similar here. We're going to acquire an ID, verify that that ID is not invalid, and then we're going to go ahead and get a pointer to that lookup at the state pointer system fonts sub ID. And then we'll go ahead and search to see if we actually have a variant that is of the font size that we're passing in, right? So if we were to go ahead and request 20 at this point, then we would already have that variant and we could just return it. And all we'll need to do is just increment the reference count and go ahead and set the text data, which is our pointer to our font data, to the address of lookup size variance sub I, right? So if we have that, then right here we are good. We don't have to do anything else. If we get to the bottom of this and we basically exit this for loop, that means we don't have a variant. So that is essentially going to say we don't have a variant to create, or we don't have a variant to return, so create one. And of course, that's going to use the lookup, the font size, font name, and fill out a new variant. At this case, we have failed to create variant. If we have failed that, I'm not 100% sure if I want to boot out from this or not. It is an error. You know what? I think, because I wasn't 100% sure how I wanted to handle this, but I suppose if that fails, we should really return false here. Yeah, that should be fine. So we'll go ahead and return false if creating a system font variant fails for any reason. So just like we did before when we created the default variant, once we create that, we also need to run setup font data on it. And then, of course, we need to add the lookup, or add the entry, rather, to the lookup's size variance. So increment the reference counter, go ahead and set up the text data, the UI text data to use the size variant that we have here. We jam this into the array. Pretty standard stuff, right? And that is actually all we need to do for acquisition. So there's not a whole heck of a lot. It's just in this case, if we go to acquire, if we have a font that already exists, a face that already exists, then we just check for a variant, because a variant we can create on the fly, but a face we can't. So at least not yet. So that is basically all that's doing. So there's not anything too crazy there. All right. So The next thing that we probably will take a look at is the verify atlas. So you may recall before, bitmap fonts don't have an atlas to be verified because they're basically just already generated, like they can't be updated, so there's nothing really to verify. And so all we're going to do is add a block here for system fonts. In fact, I'm going to change this to an else if. Right. So if the font type is of system, then we go ahead and retrieve the lookup, right, which is standard steps. I probably ought to put that into a function, maybe. Because I've done that 2 or 3 times now. I might change that to a function. But for right now, I'm not going to worry about it. So we get a lookup, and then we return the result of verify system font size variant. So this is going to be the function that actually goes through the variant, checks all the code points that exist, makes sure that we have all the code points that are needed by this text string, and creates any new ones if need be. Okay, so that is it for verify font atlas, at least for right now. So the next thing that we're going to have to do is fill out all of our private methods, right? So we created 3 new private methods here. We have create system font variant, rebuild system font variant atlas, and then verify system font size variant. So we're going to come all the way down here to the bottom, and we are going to declare first our create system font variant, right? Right. And so this is basically what is going to create our individual size variant for a particular lookup. All right. So the very first thing that we're going to want to do is we're going to want to set some of our properties, right? So we are going to go with a hard-coded atlas size of 1024 for right now. I do have a to-do in here because this probably will need to be expanded if you start using Chinese a lot or something like that. 1024 probably is not going to cut it. We probably are going to need to make that a little bit smarter and or configurable at some point as to how we do that. But for right now, to keep things simple, we're just going to roll with a 1024 by 1024 texture. So we have that, we have the size, we have the font type. We go ahead and take a copy of the face name, the internal size, allocate for the internal data, and then go ahead and grab a casted pointer of the internal data. And we're going to start off with some default code points. And I mentioned this before. This is actually going to be code points, ASCII code points rather, 32 through 127. So that is 95 code points. And so that is basically going to be a space and then everything up to ASCII code 127. And then we are also going to include a -1 for unknown, okay? And we'll come back to what we're going to use for that in a second. But we always need that -1 for an unknown character in case we're not able to generate a glyph for it. We've got something that we can output. So the first thing that we do is we push the -1 code point because that's going to be the very first thing. And then we just loop through 95 times and say internal data code points sub I+1 equals I+32. And that is going to give us our code points 32 up to 127. We then call the darray length set since we reserved 96 here, but we only pushed once. Our length would technically be 1 at this point, which is not what we would want. We want our length to actually be set to 96 because we were just setting the data raw here. We weren't pushing, that length never would have been updated. So we set that to 96. And then we're going to go ahead and create our texture. So we are going to set it up to have a texture that is based on the font texture name. And the way that we're going to do that is we're going to use a string format to handle this. So we're basically going to call any of these auto-generated textures __ system _ text _ atlas, and then we have a string here which is going to be the font name _ I And then we're going to output the index and then an underscore and then the SZ, which is going to be the size. So we'll put that here, followed by 2 underscores. If anybody has a collision off of that texture name, I'll be really, really surprised. So this should definitely be unique enough, and I'll probably wind up putting in the documentation, hey, don't name your things anything like this. Okay, so we have that. And then we go ahead and we call the texture system to acquire a writable texture, because we actually need a writable texture in this case because we are going to be generating the glyphs ourselves and writing those things out. Okay, so the next thing that we need to do is we need to obtain some metrics about the font that we are going to be generating. So we need this scale, which is the SBTT scale for pixel height. And this basically takes a look at the provided font info and then the pixel size that we want, and it obtains a scale factor that it uses internally when generating glyphs. We're also going to go ahead and get the vertical font metrics, which is what this function does. And that gives us the ascent, descent, and line gap. And so there is documentation on what all that stuff is as well. But essentially we can use these to generate our line height. So line height is basically equal to ascent minus descent plus line gap. And then we multiply that times the scale that we got before. And that gives us our line height in pixels. And finally, at least for this step, we are going to go ahead and rebuild the font variant atlas. So that is actually going to be the next thing that we are going to do. So we create our font variant here, and then we're saying, okay, well, now we've got our font variant created. We have some of our metrics. Let's go ahead and use that information to generate our atlas. So that is going to be the next thing that we define. So that simply takes a pointer to a lookup and a pointer to a variant to generate an atlas for. And we're going to go ahead and grab, for convenience, an internal data casted pointer. And we're going to go ahead and set up some data. So the pack image size is going to be basically the size of the texture that we're going to create. So it's going to be atlas size X, atlas size Y. We'll multiply those together and then times a U8. And that is basically going to give us the size that we need for our texture. Then our pixels are going to be, we're just going to allocate an array of that size. Our code point count is basically just going to be the array length of the code points that we've already gotten in the previous step. The packed characters are basically going to be a whole bunch of these SBTT, I can't get that sequence of letters correct for some reason, packed char structures times the code point count. So there's basically going to be one of these per individual glyph, right? So you can think of this as sort of a glyph as to what we've had before. So it gives an X and a Y position, some offsets, X advance, and some other offsets, right? So we're going to use about half of that. And so we go ahead and set up arrays for those things. And then we call the method that does all the work, where it takes, it basically begins packing all known characters into the atlas. This creates a single channel image with returned glyphs at the given size. So jumping back up here to the image size for a second, you might have expected this to be ×4 for RGBA, but we are not actually going to be doing that. So SBT or STB TrueType actually gives us a single channel image, and we're actually going to have to expand that out. But at least for right now, that's what they're going to wind up giving us. So this takes a bunch of parameters. It takes the STBTT pack context, which is what it's going to create a new one of these. So it just takes a pointer to one of those. The pixels array for the actual memory itself, the pixel memory, the X dimension, the Y dimension, and then these other properties are, let's see, whoops. The stride in bytes, which is 0, because it's basically going to be 1 byte at a time. The padding, there is 1 byte of padding, and then there is the allocation context, I think it was. I forget exactly what that is, but we're not using it, so we pass 0 there. So what we do next is this sort of begins that process, and then we call stbtt pack font ranges. And so that takes this range, this pack range structure, which basically says the first Unicode code point in range. In this case, we want 0. The font size, obviously, the number of code points, the character data for the range. So that's going to be our packed characters that we built up here. And then the array of Unicode code points. That's going to be our internal data code points that we have generated before. So our 96 characters of ASCII, or whatever it happens to be. And then we call our stbtt pack font ranges. We pass it the context, the binary, the lookup index, the range, and then that 1 is for the number of ranges, which we only have 1. Okay, so this could technically be in different ranges of code points. We could pass multiple ranges of these if we wanted, but we only actually need 1. So if that fails for some reason, then we bleed to button and return false. Otherwise, we continue on. So at this point, we will have packed everything we needed, so we can just say stbtt pack end, which sort of wraps all that up. And then at this point, we can convert from single channel to RGBA. And basically, this is going to be the pack image size times 4. So we're going to allocate some memory for that. So there's our RGBA pixels, pack image size times 4. And then we're basically going to go through here, and we are going to take each individual RGBA, or each individual pixel, right, at index J, and put that into the RGBA output of our new image, or RGBA pixels, right? So we're basically just duplicating that data. Next, we go ahead and we take that data and we write it to our texture. So we have our variant atlas texture. We write that from the beginning of the texture. This is the size of it, and then the data to actually be written. So we just go ahead and write all of that pixel data to our texture. And then at this point, we go ahead and we clean up. So we free our pixel data and our RGBA pixels, because we don't want to leak that memory. And then at this point, we need to go ahead and regenerate our glyphs. So that is done first off by, if we already have a glyphs array and there was a variant glyph count, we go ahead and free that array, because we're likely doing this because we have a different number of glyphs, probably an increase. And so we're going to need a new allocation for that. So if it existed, we're going to free it. If it didn't exist, then it's the first time we load it. We don't have to worry about it. So here is our glyph count. We fill that out. We create a new glyphs array. And then we loop through, and we actually just set all of our information out of our packed character array to our Kohi font glyph, right? So we take a pointer to each one of these things, and then we sort of convert them to the data that we expect. So the G code point would be the internal data code points sub I. The page ID is going to be 0. This is another case where we're not going to, at least right off the bat, support multi-page fonts. The X offset is obviously equal to the packed character X off. Same with Y offset, just Y off. The X is packed character X0, and then Y is Y0. The width is going to be the X1 minus the X0, so that's basically the difference between the left and the right side there, and then the top and the bottom here. And of course, we just use the X advance as is. So that's sort of how those that conversion from their data structure to ours is done. So the next thing we're going to do is almost the exact same process, except for the fact that we are going to do this with kernings. So first, if we have a kernings array, we're going to go ahead and wipe it out. And then we're going to go ahead and get a kerning count from the lookup info itself. So this is another thing that would have been generated under the hood when we go ahead and make all these function calls further up here. So we're going to get kerning table length, which is basically how many kerning entries we have. And then we're going to loop through that count. And then we're going to essentially, sorry, not loop yet. If we have a kerning count at all that's greater than 0, then we allocate some memory for it. And then we need to get the kerning table for the current font. So we're actually going to need to allocate some memory for that as well. And then we can say get the kerning table. It'll fill this out. And then we are just going to do some double checking to make sure that the variant kerning count and the entry count are sort of the same, because this function should return and how many entries are in our kerning table, which should match what we've got up here. So we'll just verify that real quick, and then we're going to loop through our kerning counts and grab a pointer to a kerning, set code point 0 to kerning table sub I glyph 1, kerning point code point 1 will be kerning table sub I glyph 2, and then we also have an amount here, which is our advance. So it lines up pretty nicely. And then of course, if we don't have a kerning count, we're just going to set kernings to 0. And that is pretty much it for this. All we need to do is, since it returns a Boolean, we need to return true. If we get to this point, we have successfully regenerated our atlas. Okay, so we're almost done. The last thing that we actually have to do is we have to verify our system font size variant. So this is where we are actually going to take a look at the text itself, as well as what is available in variant, and check to see if we have all the characters that we need in order to render this string of text. And if not, go ahead and regenerate the atlas. All right, so first we'll take a convenience pointer to the internal data, just as we've done before. And I'm actually going to put this whole thing into place, right? Or almost the whole thing. So what we're going to do is we are going to keep the character length of the string. So this is not the UTF version of that. We're going to, this is basically the byte length of the string. And then we're going to keep a running total of how many code points we've added. And we'll loop through each individual character, grab a code point and an advance, right, using our bytes to code point. So we'll go ahead and do that. Obviously, tracking any errors if we have them. And then if we're successful, we'll go ahead and move I forward. And then if the code point is less than 128, that means it's an ASCII character. We could just use it as is. And we should also have guaranteed that that already exists, right? Because we don't actually need to check that because we know that all of our variants actually use the ASCII characters by default. So we don't actually need to check that. Otherwise, we go ahead and get the code point count, which I suppose we don't really need to do this on every iteration of the loop. Thinking about it, let's see, we probably... Yeah, this can actually go up here. So let's move this up here so that we only take that code point count once. Wait a minute, though. No, we don't want to do that. That's going to cause a bug. Ignore that. And I'll explain that in a second. So we want to get the current code point, and then we'll have a found flag that we default to false. We will loop through starting at index 95, right? Because we've already added 96 characters to this, right? So we'll check. We'll start here at 95. meaning start past all the auto-generated stuff. And then just do a comparison to say, hey, if the internal data code points sub j equals the code point, then we found the code point and we can continue on. If we get all the way through the end of our code points and we have not found a matching code point, then that means that we actually have to add a new one. So we go ahead and push that code point into our internal data code points, and then update the added code point count, right? Which means if we wind up pushing this, that would mean that if we only took this count once, it would actually be wrong at this point. And so on every loop, we actually do want to retake that count. All right, so with that, if we get to the bottom here and we had code points that were added, then we're going to return the value of rebuild SystemFont variant atlas. So that means we're just going to say, okay, we need to rebuild this on the fly, do it, and then return the result of that. If we do not, then we're just basically going to proceed as normal. And we're just going to return true, indicating that the validation was successful. And that is the end of our font system updates to support system fonts. So I know that was kind of long-winded, and there was a lot that goes into it, but you know, it's definitely going to allow us to have a more flexible system for sure. So the last piece of this is to actually hook this up and use it. So I'm going to go to Application, and we'll go to our application state, actually all the way to the bottom here. We don't need to stand up any new systems or anything like that. We are simply going to add another UI text object. We're going to call this test systext. Great name, I know. But, you know, it is what it is. And then we're going to go down to where we initialize the font system. Here we go. So before we were basically having a default system font count of 0, and then system font count configs, or system font configs is 0. I'm going to delete that, and in its place, we're going to have a new system font config. Our default size is going to be 20. The config name is going to be Noto Sans, and then the resource name is going to be Noto Sans CJK. So that's what's going to link that to pick up our font config here, right? So that name needs to match that. And then our default system font count is going to be 1. Our system font configs could be an array, but since we only have 1, I'm just going to use the address of system font config. I'm going to go down a little bit here. Let's see, where we're creating UI text, and we're actually going to create another UI text. So this one's going to be of type system, using the Noto Sans CJK JP version of this. We're going to use font size 31, so this is that 31 I was talking about. And we're going to use a little bit different of a string here. So we're going to use some system text, 1, 2, 3, new line. Let's go ahead and tab this too, right, just to keep it kind of consistent. And then we're going to have 2 new lines, and then another tab. And then we're going to use this Japanese text here, which is konnichiwa, and then this Korean character here, just to validate that that works as well. And then we'll go ahead and save all of this at the address of test system text, right? And so we've got that, and then we are going to set the position of that just a little bit lower, so it'll be at 5200 instead of 5100. And then all we have to do is hook up some stuff down here in the loop for our packet. So we've got our render packets. Let's see, where is our UI stuff here? So we've got, here we go. So we have, that would be my wife calling for my dog. Hold on one second. Okay, sorry about that. All right, so we have our UI meshes here. So where are we? We're doing our text here. So this is actually where we're going to want to add this. So we have our text count is going to be 2 now. Our text array is going to be 2. And I'm actually just going to copy this line here. We'll change this to sub1. And we want test system text for that second one. And then a little bit further down where we destroy this stuff, we are also going to destroy our test system text. And that should be everything we need to do. Bring this up a little bit. So it looks like we built fine. So let's go ahead and run. And hopefully I didn't miss anything and it runs. Yep. Okay. So here we can see our different fonts being loaded. So we still have our camera font here that's using our monospace font, but now we see our new system font actually loading up using our TTC. And we can see here that we have our Japanese characters here as well as our little Korean character here. So now we have support for system fonts. We have very basic support for a lot of these sort of other international languages. Again, though, this only does support left to right. We do not have right to left support yet. We do not have any sort of support for script type fonts for languages like Hebrew or Arabic. Those are the two that come to mind. And so those will definitely have to be handled in another pass because there's a lot of complexity that goes behind those and the way those characters connect. So for right now, those things aren't supported. So anyways, I hope you guys have been enjoying this series. I hope you've learned. And that is pretty much going to do it. So if you guys haven't already, please consider subscribing. Toss me a thumbs up. That really helps me out a lot. And yeah, I will see you guys in the next one.